Hey there, this is my very rudimentary version of a Khan Academy tutorial video on the 3 methods of long division that we will be learning in 4th grade this year. Because they are not, 2 of them at least, the ones that most of us parents are familiar with, I thought it might be helpful to have a tutorial both for students and parents to kind of understand how this works. So you'll see the division problem I'm using as an example is 3,897 divided by 4, which is not so easy to do in your head, so usually we would require some long division. And there are 3 ways that we encourage the students to try solving these problems so that they not only can solve them accurately, but get a conceptual method, understand what they're doing when they're dividing a big number into equal parts. So they've learned the rectangle method or area model of multiplication, meaning they multiply each place value by the number they're multiplying to find the different partial products that then add up to give you the total answer. So when we do division with the rectangle method, we basically do that same system but backwards. So we start with a big rectangle, and we write in the very top left corner the giant number that we are dividing into, the dividend, and we put the divisor over on the left. The first trickiest part to this method is that the students need to think, what kind of place value am I going to be getting for my very first section of division? If I divide into 3,897 by 4, will I be able to get something in the thousands place, or will I be starting in the hundreds? So they do have to ask themselves first, should I be writing a number up here that'll be a thousands number or a hundreds number? Hopefully they see I'm not going to be able to get a whole 1,000 groups of 4 in 3,897. I'm going to have to start with hundreds. So we tell them to put that blank over the hundreds and then go ahead and add the 2 zeros, because you're really just finding how many hundreds of groups of 4 can I get initially out of this big number. And so that does require them then to look at the amount of hundreds in the dividend. There are 38 hundreds, right, in the dividend. And so I can, if I know my math facts, say to myself, and sometimes I encourage the students to write their 4s to the side if they need help. I know it's 4, 8, 12, 16, 20, 24, 28. I can think of my 4s all the way up to 12s if I need to, all the way down to 48. And if it helps me, I can do it that way to say, wow, I know there are 8 4s and 30 would give me 32. Oh, but that's not big enough, because I could actually get 9 sets of 4 or 900 4s to get to 3,600. I can't, of course, go all the way to 10 4s or 1,000 as we discussed before. So I'm going to take 900 4s because I think that's the most I can get out of this 3,897. And then I go ahead and do that. I actually take 900 groups of 4 out. I subtract and I get 297 left. That's when I can then divide my rectangle, bring my 297 that's left up to the next section, and say now I'm going to be worrying about how many tens of groups of 4s I can take out. Then again, I'm going to be looking at the tens, the number of tens. I do have a hundreds number, but I couldn't get another 100 4s out, so I'm looking at the tens left. There are 29 tens in 297. So I will look again at my chart and say, ooh, the closest I could get then would probably be 70 4s, because that would give me 280. So that's what I'm going to do next. I go ahead and subtract, and then I get one more section because I realize, oh, I'm getting to the ones. I have just a few groups of 4 left, only up to 10, right? I won't even get up to 10. I've just got a few groups left, and this is where our math facts hopefully pop right into our head, and we say, oh gosh, yes, I know for a fact that 4 4s is going to be really close to 17. So I'll take that, subtract, and see that I do have a remainder. Then I can just, in my head, add up the number of 4 groups that I was able to take out, add my remainder, and I have my answer. That's what we call the area model or rectangle method for long division. The next method that we teach the kids is something that I call the chip away method. Some people I've heard call it the Big Seven, and the official book title is the partial quotients method, and you'll see why as we do that problem, if I can keep my camera from falling over on us. So, the partial quotients method means that I just kind of get to pick a number. I just estimate. I just do the best I can. I go ahead and write my long division problem. And in fact, I'm going to go ahead and remember that because I'm chipping away, I'm going to need a little extra room up above. So I write my long division bracket like I normally would, but I give a big long tail because we're going to be doing some things on the right. And so I kind of start similarly where I say to myself, can I get a whole 1,000 fours out of there? Or just hundreds of fours? So I encourage students to think about taking maybe 5 fours, 10 fours, 50 fours, 100 fours, maybe 500, maybe even 1,000. I tell them, think about some nice, easy round numbers and start there. Can I get a whole 1,000 fours out of this dividend that I have? No, but it's close. So I probably could do something like 500 fours. I'm just going to pick a nice round number and say, let's take 500 fours out of there. Well, how much is 500 groups of fours? It's 2,000, right? I'm going to multiply 500 by 4. Say 4 groups of 500 or 500 groups of 4 would be 2,000. So then I just go ahead and try that. And I see what I subtract and get. I end up with 1,897 left. Could I do another 500 groups of 4 then? No, I don't have as much as 200, but I could do close. So maybe I'll do 400 more 4s. And so you'll see that I'm really just guesstimating, kind of. I'm just chipping away at the total by using some big, nice round numbers and taking away whatever seems reasonable. So I'm going to go ahead and see if I can't take another 400 groups of 4 out of there, which I'm pretty sure I can. If I do the math, I see, well, that would be 1,600, and I do have enough to do that. So I subtract to see what's left. I've chipped away again. Well, now I've got a very significantly smaller number. I did a really good job chipping away at this number. So now I only have 297 left. So I think I look over here and think, well, I don't think I can do another 100 fours even. That would be 400. Maybe 50 more fours if I think about that mental math. Yeah, I probably can do 50 more fours. That would be 200 I'd get to take away. Now I'm down to 97. I'm still not into my 4 facts that I know, right? This is still a pretty big number, but I do know I could take 40 away from that, right? A group of 10 fours. So I'll go ahead and take 40 away. That leaves me 57. Oh gosh, then I could take another 40 away. I'll take another 40, and that leaves me, if we scoot up a little bit there, with 17 left. And then I'm once again finally at that spot where I say, oh, that's a fact I recognize. If I do 4 more 4s, I'll get 16 with 1 left over. Now you can see this is a paper-consuming method, but some students like this method. It sort of makes sense to them. They get to just choose numbers and chip away at it. So ultimately then they have to either in their head or on paper add up all those amounts they took. Some people write them to the side here and add them up that way. 500, 400, 50, 10, 10, and 4. And then they can add up all of those numbers, and you'll see that again I end up with that same answer of 974 with a remainder of 1 as my quotient, my final answer. So the last method, of course, thanks for sticking with me, is what most of us learned as the traditional digit by digit long division method when we were kids. We teach a fun little mnemonic to help kids remember that it's dad, mom, we relate it to a family, sister, brother, and rover. Think of it as a little family to remind them that first you divide, then you multiply, then you subtract, bring down, and repeat or have a remainder. The reason, though, that this is the third method that we teach, and the reason that even though many of us survived all our lives only knowing how to do division through this method, the reason we teach it third is because it requires more keeping the numbers in your head mentally And it doesn't as much show the real conceptual understanding of what we're doing, that we are actually dividing a big number into many groups to make equal groups of 4. So this method is maybe the quickest, and when you get good at your facts, it may be the easiest, but does not require the most conceptual understanding. However, and I'm going to show you 2 ways we can do this if you're super good in your mental math. There's an even super shortcut method, but this we would normally say, as you know, can 4 go into 3? No, it cannot, so I will go all the way to the tens place, the hundreds place instead of starting at the thousands, and say, can 4 go into 38? Yes, it can. What's the closest fact? It is, of course, 9 groups of 4. I will go ahead and take those 9 groups, and the nice part about the digit by digit, just like with multiplication, is I never do have to think in hundreds or thousands. Even though that's really what I'm doing, I'm really dividing into the hundreds place here. I don't have to think of it as 3,600. I don't have to write those zeros. I can just do it digit by digit. So that's why the book calls it that. Digit by digit, because I've got the number going into the proper place value, as long as I'm lining things up properly. And so I don't have to remember that I'm doing the hundreds place or the tens place. I just go digit by digit. So I was in the first 2 digits. I'll go ahead and see how many hundreds are left over, but I just really think of it as 38 minus 36. But then because I haven't done the tens place, I'll now bring down, that's my B, the 9 from the tens place, and now I will repeat or go ahead and divide the 4 into the new leftover amount, which is 29 hundredths. So a lot like what I was doing way over here. But this time I don't have to really think about what I'm doing. I just have to go digit by digit. So now I know the closest fact I can get is 4 times 7, which gives me 28. I'll go ahead and subtract, see what's left over, bring down the next place value, and now I'm down to 17. You see how much quicker it goes. I know my facts that I can get 4 groups of 4 out of 17. That means 16. I have 1 left over, and my remainder is 1, and my answer is already written for me. I didn't have to do any adding up at the end because I simply kept my place values lined up perfectly, and I end up with the answer of 974, remainder 1, which is exactly what we got with the other methods. As kids get really good with their facts and get more comfortable, I do often teach them that if they're real good with their mental math, they can do this all without any of the long tails of long division. They simply say, can 4 go into 3? No. Can 4 go into 38? Yes, 9 times. With 2 left over, I simply put the 2 here to remember. Okay, so that's what's left. Now I'm going into 29. 4 into 29, 7 times. That's 28 with 1 left over. Going 4 into 17, that's 4 times. That's 16. I know my remainder is 1. I'm done. So that's the super shortcut method if you're good at keeping the numbers in your head. Those are the 3 methods the kids will be learning for long division. And hopefully now you have an idea what crazy stuff we're doing in class and can maybe help guide them or at least understand what they're being expected to be able to explain or make sense of during this unit. Thanks so much for watching.